Welcome to the third lesson on electric circuits. So now we're going to do examples where there are series and parallel in one circuit. So now you have to get your equations in order. Okay, so for the following circuit, calculate the current through the cell, which is then the total current, the potential difference across R4, which is for this resistor, and the current through R2, which is for that resistor. So let's look at A, the current through the cell. Remember Ohm's law, R is V over I. Now it's very important. For this equation, you need to use the same values that are structured together. So you need to use the total resistance, the total volts, to get to the total current. So we don't have the total resistance. We have R1, R2, R3 and R4. So first we have to calculate the total resistance. Total resistance would then be the resistance in series, which is these two, plus the resistance in parallel. So R series is then R1 plus R4, which is 2 ohms plus 1.5 ohm. You do the substitution and you simply add them together to get the resistance in series as 3.5 ohms. Now we have to calculate the resistors in parallel. So the resistance in parallel is 1 over the resistance in parallel equals 1 over R2, which is given, 1 over R plus 1 over R3, which is also given in the question. So let's substitute the values. R2 is 1 ohm. R3 is 1 ohm. So 1 and 1. And this is not that difficult math. So 1 plus 1 would then give you 2 over 1. But remember, this is 1 over R parallel. You want R parallel. So now you have to switch your fractions. Then you get R parallel is equal to 1 over 2. So now you can get to the total resistance, which is the resistance in series and the resistance in parallel. These we just calculated to be 3.5 ohms plus 0.5 ohms, which gives you 4 ohms. Now, finally, we can get to the question, the current through the cell. We have the total resistance, as we just calculated, 4 ohms. And we have the total voltage, which is 10 ohms, divided by the I, which you want. So now you rearrange your equation to get the total current, 10 volts, divided by 4 ohms, which gives you 2.5 amperes. Part B, the potential difference across R4. So, Ohm's law, R is V over I. The resistance in R4 is 1.5 ohms. V, you want to calculate the potential difference over R4. And then the current would be the total current, since this resistor is in series. So the total current flows through it. If you rearrange your numbers, you'll get to 2.5 amperes multiplied by 1.5 ohms, which then gives you 3.75 volts, which is the potential difference across R4. Part C asks the current through R2. Now remember, for a parallel circuit, here comes the total current, total current, total current. Then here it splits up. One part goes through R2, the other part goes through R3. We want the current through R2. But first we need the voltage through R2. The voltage in this parallel circuit would be equal to the voltage in R2. Now we use Ohm's law. R is V over I. But remember, we need R in parallel and the I parallel. So then the R parallel we calculated previously to be 0.5 ohms, and the current flowing into the parallel circuit is 2.5 amperes. The potential difference for R2 is then 2.5 amperes multiplied by 0.5 ohms. That gives you the voltage over R2, 1.25 volts. Now we can get to the current through R2. You now use R is V over I, but for the values of R2. R2 is 1 ohm, given in the question. The volts we just calculated is 1.25, and you want the current through R2. So the current is then 1.25 volts divided by 1 ohm, which gives you 1.25 amperes. Example 2. Calculate the equivalent resistance of a 6 ohm resistor in series with 2 resistors in parallel. Now remember, the total resistance is the resistance in series plus the resistance in parallel. They say a 6 ohm resistor in series, so that is 6 ohms, with 2 resistors in parallel. So we still need to calculate R parallel. So 1 over R parallel is 1 over R2 plus 1 over R3. R2 is 4 ohms, R3 is 2 ohms. So we substitute the numbers. Now we have to add these two equations. So you put them over 4, which then gives you 1 plus 2. 1 over R parallel is then 3 over 4. But we want R parallel. Therefore, we have to switch the fractions top to bottom. R parallel is then 4 over 3. Now we can get to the total resistance. The total resistance is the resistance in series, which is 6 ohms, plus the resistance in parallel, which we just calculated to be 1.33 ohms. That gives you the total resistance in 7.33 ohms. Example 3. Determine the equivalent resistance for the following circuit. Now again, we have a circuit which have resistance in series for where the total current flows through, and then we have these two resistors in parallel where the current splits up. One part goes there, the other part goes there. The total resistance is then the resistance in series plus the resistance in parallel. So let's use our equations. The resistance in series is resistor 1 plus resistor 2, 6 ohms plus 4 ohms, which then gives you 10 ohms. The resistance in parallel is then 1 over R parallel is equal to 1 over R1 plus 1 over R2. R1 is 1 ohm, R2 is 2 ohms. So now you add them together to get 2 plus 1 over 2, which is then 3 over 2. Very important, we want R parallel, so we have to switch our fractions top to bottom. That gives you 2 over 3. Now we can get to the final answer of the question. The total resistance is the resistance in series plus the resistance in parallel. The resistance in series is 10 ohms as previously calculated, plus the resistance in parallel, which is 0.67 ohms as calculated on the previous slide. That brings us to 10.67 ohms, the total resistance. Thank you.